Hi, I'm Jeff Giroux. I work at Hydro Air 40th Street. Basically, the customer was running the pump and they experienced a step change in vibration. And what that means is you have a baseline where it's running good and smooth. Step change is it jumps up in vibration, and when you get past a certain point, which is 0.3, that's when you got to stop the pump. On this pump, this is a 100% pump, so that means there's one pump on the unit. If this pump fails, that means the unit gets shut down. Now, if this happens in the summertime, peak season, that means that that customer has to buy electricity to provide to their customers, which can cost them up to $1 million a day in revenue. When we receive the element, the first thing we do is we check for lift at both ends. We weren't able to do that on the one end, the pump wouldn't move. The volute was then disassembled, and this is when evidence was found of a catastrophic failure in the fourth stage. The forensic and metallurgical analysis was done to verify that there was no problems in the previous welding on this casing. After doing our root cause analysis and metallurgical examination, we determined there was not a failure due to welding of the volute, but it was a failure due to the casting of the volute. And what happened was there was a core shift creating a very thin area supporting a stage piece where you should have an even support over the whole stage piece. The area was a 1/4 inch thick compared to being a 1/2 inch thick. And by having that, there's no support on that stage piece, so when the pump loads and unloads, that stage piece deflects that area until it fractures due to deflection. A big chunk came out of the sidewall of the volute and went into the fourth stage back hub impeller, and then got pushed through the volute into the fifth stage, and then got pushed out through the discharge nozzle.
Boiler feed pumps in power stations are one of the most critical pieces of equipment, and they're always high energy, multi-stage BB5 barrel pumps. With that level of equipment and the energy that's needed to drive that equipment, it's very important that the geometry of the hydraulic bundle within the barrel is precisely manufactured. A lot of time and a lot of effort goes into welding that case because the damage is extensive and the repair needs to be done in a very meticulous way to make sure that all the areas of damage are repaired. This type of error can occur at the factory when the pump is first manufactured. And the reason for this is generally poor inspection process within the manufacturer. In this particular instance, I believe that the area where the failure occurred was potentially not picked up because the original manufacturer wanted to satisfy the customer by sending the casing in a good time frame. Unfortunately, the cost of poor quality is remembered much longer than late delivery.
One thing that makes Hydro what Hydro is today is this ability to provide a solution. In this case, Hydro was able to provide the customer with a full spectrum of capabilities, which included the repair of the element, the engineering, the metallurgical examination, and the root cause analysis of the failure. Today we have a very happy customer. They can install it right away without losing $1 million a day.